Alright, so after looking at limits, we're going to look at hyperbolas now. So the general hyperbola is y equals a over x, or if rearranged, you can get yx equals a. But the main thing here is there's an x on the bottom of a fraction, so that's what makes it a hyperbola. So notice how the basic one we have here, y equals 1 over x, we can't have 0 in the denominator, so that means that makes x equals 0 our asymptote. Oh yeah, technically I should say that x cannot equal 0. So yeah, so you can use that when you're finding the domain of the hyperbolas to find the range. So usually there's a horizontal asymptote at y equals 0 for the basic graph. Normally we find this just by taking the limit as x heads to infinity or looking at the y values of the domain. So now here, this is our basic one, y equals 1 over x. So we did the negative version of the graph. As you can probably tell, it'll just switch quadrants. So I'll go over here and here. So this is one of the most basic ones, y equals negative 1 over x. So, yeah, so with the basic one, just remember the asymptotes are at x cannot equal to 0 and y cannot equal to 0. So let's get onto some harder ones. So by looking at this first, the first thing we want to find out is the asymptote. So the denominator can't be 0. So we know 3x plus 2 cannot equal to 0. And then yeah, just solve it. So you should get x cannot equal to negative 2 over 3. So some other features of the graphs that we need to find are pretty much the x or y intercepts if they exist. So let's find the x-intercept. So that's when y equals 0, so 0 equals 5 over 3x plus 2. So if we times both sides by 3x plus 2 to get rid of the fraction, we'll get 0 equals 5. So this tells us that there is no x-intercept. So the y-intercept will let x equals 0. And yeah, so you should be used to just telling it from looking at the equation now, or you can do it in your head quickly. So they'll go to 0, so it's just 5 over 2. So yeah, when we graph it, it's best to just put in our asymptotes first. So we know that x cannot equal to negative 2 over 3. Alright, so one thing I want you to keep in mind is, remember how before we had brackets, it shifted the graph left or right? So in this case, having the 3x plus 2 on the bottom does a similar thing. So it's shifted the asymptote to the left. So it's left negative 2 over 3. So we can tell that this is a positive graph, so it will be in the same quadrants as the positive version. And we know that it cuts at 5 over 2 on the y-intercept. So the graph's just going to look like that. So think about your basic graph. We haven't really done anything to shift the y asymptote. So it just stays at y equals 0. And it's obvious because there is no x-intercepts there. So yeah, that's just one thing to keep in mind. So it's just a graph shifted to the left. So the next one, it's the same thing, but because of that negative, it just changes quadrants. But yeah, let's just do the domain and range for this graph first. So the domain for this graph is all real x except where the asymptote is. So, comma, x cannot equal to negative 2 and 3. And the range is all real y except y cannot equal to 0. So yes, I'll just graph the other one quickly. So it's pretty much just the same. So we've done all our working out. So negative 2 and 3. And obviously having a negative there is just going to change the y-intercept to negative 5 and 2. But apart from that, our graph is just the same, just in different quadrants. So I'll cut through there, and I'll go through there. Alright, so now let's look at the next one. So let's analyze it before we graph it. So obviously it's a negative graph because there's a negative in front of the x. So the way I like to think of this graph is, this is just a basic graph that's shifted to the right because of when we find the x asymptote. And the plus 5, so remember what the plus in constants has done to all the other graphs, it just shifts it up 5. So yeah, let's just do this one now. So we'll find the x asymptote, so 6 minus 3x can't equal to 0. So if we solve that, we get 3x can't equal to 6, and then x can't equal to. Some other important features we're going to find are the x and y intercepts. So let's find the x-intercept first. So x-intercept, let y equal 0. So I'm just going to times through everything by the denominator just to get rid of it. So yeah, so if you expand and solve this, so I'll let you guys do that, you eventually get x equals 31 over 15. So the y-intercept with x equals 0, so we get 1 over 6 plus 5. So that we know the y-intercept is going to be 5 and 1/6 from just looking at the equation. Alright, so let's graph this now. So know that at x equals 2, there's an asymptote. So notice this plus 5, it shifts that original asymptote at y equals 0 up 5. So that's 5 there. I know that's 2. So we know it's a negative graph. So we know it's going to be in these two quadrants. And what helps us in this case is also knowing the intercepts. So 31 over 15 is just a bit more than 2. So this graph's obviously not to scale. But it just gives us an indication that it's going to be on this side. So it's going to be there. And 5 and 1/6 is roughly, would be up here somewhere. So Yeah, this is definitely not to scale, but it gives you an idea of how to do it. So let's find the domain and range for this graph. So domain is all real x except x cannot equal to 2. And the range is all real y except y can't equal to 5. Alright, so for this next question, we're going to modify it so it's similar to the previous question. So that means we can sort of see how the graph's going to shift. So a little algebra trick we do is x plus 2 is also can be written as x plus 1 plus 1. So with that we can split the numerator. So we can get x plus 1 over x plus 1, which gives us a whole 1, plus 1 over x plus 1. So yeah, so from this graph, from analyzing it, we know that x can't be negative 1, and that the graph's going to be shifted up 1. Alright, so if we quickly find the y-intercept, we get 2, and it's a positive graph, so we know it's going to be in that quadrant and this quadrant. So yeah, so remember you can find that point by just subbing in y equals 0, but I'll let you guys do that. So yeah, I hope you guys are getting an idea of how to quickly shift these graphs and find them. Alright, so now we're going to move on to harder cases. Alright, so for these harder graphs, since we can't modify this equation to make it simple like the questions earlier, we're going to have to use a different method. So we're going to keep it the same first, so we're going to find the x asymptote. So you figure it out, you get x equals kind of equal to a half. And then you find the x and y intercepts. So yeah, so just do it as we did before. So if you figure it out, it would be x equals negative 2 over 3. And the y-intercept, we can just see would be 2 over negative 1, which is just negative 2. Alright, so what we're going to do differently for this one now is we're just going to analyze the graph near the asymptotes and as it goes towards infinity. So as x heads towards infinity, we want to find out what y heads towards. Alright, so we're going to type that in our calculator. So 3 times x, I picked a really big number, so 4 nines plus 2, and then 2 times 4 nines minus 1. You see that it heads towards 1.5, but it's bigger than 1.5, so it's on the positive side of it. So 1.5 plus. So we want to test the same thing as x heads towards negative infinity. So we're just going to sub in a really big negative number. So yeah, so once you have it typed in your calculator, just set it up so that your x is always in brackets. So you can just change whatever's in brackets. So in this case, we're going to change it to a negative. And you can see it's 1.49. So now it's on the other side of 1.5. So yeah, so from our graph now, that tells us that 1.5 is the y asymptote. And we figured out before the x asymptote is a half. So yeah, so what I like to do now is I also want to test as x heads towards this x asymptote. So we want to test as x heads towards a half, but on the left side and on the right side. So yeah, we want to test where the y values head towards. So let's go back to our calculator. So we know a half is 0.5, so we want a number that's really close to 0.5. So I'm just going to put 0.5 and then 0.001. And then we know that that's a big number, so that's just saying it heads towards infinity. So we want a number on the left side of 0.5 that's small, so it's like 0.4, and then we just put 3 nines. And yes, you can see that heads towards negative infinity. So yeah, we'll write that down. So yeah, so now we know that the x-intercept of our graph is negative 2/3. So that'll be roughly here. Sorry, here. And the y-intercept is at negative 2. So we'll just say it's down there. And we know as x heads towards negative infinity, it heads towards 1.5 but underneath it. So keep going there. And on the left side of a half, it heads towards negative infinity. So yeah, we wrote that the wrong way around here. So just change that around. So yeah, so it should head down like that. But in your graph, it should go more towards the asymptote. And then from analyzing the other side of it, so on the right side of a half, we know it heads towards infinity, so it's just going to keep going up there. And as x heads towards infinity, it heads towards 1.5 on top of it. So we know it's going to go up there. See, this graph's a lot harder, but yeah, I'm just showing you one method to graph it. And this final graph we have at the bottom here. Alright, so if you analyzed all the things I said earlier, you'd get this as shown here. So another thing before we graph this is we test to find the intercepts. So the y-intercept is easy, so let x equals 0, and we can see that it's going to be negative 1/4. In this case, there is no x-intercepts. So if you let y equal 0, you'll see that we can't solve it. So pretty much we have all the information we need to graph now. So now let's just start on the left side here. So as x heads towards negative infinity, y heads towards 0. So it's going to be like this. And as it heads towards negative 2 on the left side, it heads towards infinity. So the graph goes up like that. So as the graph goes towards negative 2 on the right side, it heads towards negative infinity. But then on the left side of positive 2, it heads towards negative infinity again. So we know, since it cuts there, it's sort of going to be like a parabola because they both end up going down towards negative infinity. If you analyze the last section, you'll notice that it'll be like that. So yeah, this is a harder graph. So obviously this graph is not a hyperbola because there's a squared on the bottom. But yeah, so I thought I'd just chuck it in just for something a bit harder. So notice that at the bottom, it's a difference of 2 squares. So that can be written as 1 over x minus 2x plus 2. So that pretty much tells us x can't be 2 and negative 2. So maybe this is a harder question, so it's highly unlikely you'll get one of these in your test, but it's good just to know what method to use. So now we know the x and y asymptotes. Pretty much what I do is I analyze every asymptote and its x heads towards positive infinity and negative infinity. So yeah, I'll write down the answer. So you guys can give it a go on your own, but I'll just write down the answer and show you.